fractions and decimals. So once again, this is the chapter which we are going to learn and which we are going to solve based on this topic, like fractions and decimals. So have you heard the word fraction before? Have you heard the word fraction before, children? Yes, maybe in your lower classes. So if I'm asking Sai Shrestha, can you give one example? Can you give one example of fraction?
In my old school, I am in Akshara. I learned about fractions.
Wow, good. That's so nice. So can you give an example, Harsha, for fraction? Can you give one example of fraction?
Yes, sir.
Yes.
Yes, sir.
Yes. Yeah, please tell.
There are four.
I just want an example. I don't want the definition. Definition I will be defining. Don't worry. What is example? Here only you can see in this presentation only you can see some fraction is written. Anybody can answer. Anybody can answer.
Sir.
Yes, please.
1 by 4.
Yeah, 1 by 4. You're able to see here. There is what I can call it as it's a cake or something like bun, right? So here 1 by 4, 1 by 4, 1 by 4. So some part of this is missing. That is 1 by 4 is missing. Maybe Harsha already ate it, right? So this was before eating. This was before slicing this. It was a whole. It was a whole cake, like cool cake. We can see that it is melting, right? So it may be a cool cake from which it is divided into 4 parts, totally 4 parts, and in that one part is eaten by Harsha. So what we can understand that the whole is divided into 4 parts, that is by 4. So here the by 4 is showing that into how many parts it is divided, and in that one part, that is 1 by 4, is eaten by Harsha. Now how much is remaining here? 1 by 4 plus 1 by 4 plus 1 by 4. So totally 3 slices are there. So 3 by 4, 3 out of 4 parts are still remaining. So you grab it. Let me see who will grab it first. So that's not possible to grab here because that's an image. Okay. So let me move ahead. Yeah, the curtain has over here. You can see chapter 3. This is the chapter which we are going to discuss. Name of the chapter is fractions and decimals. Fractions appear like this, 1 by 4. It doesn't appear like cool cake. It appears like 1 by 4 and 3 by 4. 5 by 6. So those terms or those numbers will be called as fractions. And decimals, here you can see I have written 0.7, 2.65, 1.24. So these all numbers or this way of representation is called decimals, right? So actually this 1 by 4 is again can be written as 0.25. So I can say that fraction and decimals are nothing but they are the same number, but their form is different. Their appearance is different. Fractions can be converted as decimals, and decimals also can be converted as fractions, right? Okay. Now let me tell you that what we are going to learn in this 3rd chapter, what sub-concepts we have. What are the sub-concepts which we are going to come across? First, we will be defining the fraction. That is, will come across the definition. We'll try to define it proper manner. Then second, we'll be seeing what is types of fraction. Of course, you people said already you know, but it's my job to tell you again what are the types of fraction. And then comparison of fractions. We will be given 2 fractions and then we need to compare. Now, what do you mean by compare? Compare is nothing but to tell whether a fraction is greater than or less than or equal to another fraction. That means if 2 fractions are given, then we will be comparing them, which is greater, which is smaller, or they are equal. So that is called comparison. And then we have, the real task, that is addition of fractions. We will be starting the operation. We will do addition. Now, when I say addition of fractions, in this actually subtraction is also included. Please remember, addition of fractions means in that subtraction also will be included. Then we have multiplication of fractions. And finally, after multiplication, the next operation is division of fractions. We will be doing that also, right? Next, coming to decimal numbers, we will understand what are decimal numbers. Then even we will compare here also. We will do comparison of decimal numbers. We will do addition and subtraction of decimals. And finally, we will do multiplication and division of decimals. So here, when I say addition, subtraction is also included. Here, when I say multiplication, division is also included. Please try to understand that. If you want, you can take a screenshot of this. So these are the concepts, these are the topics which we are going to cover in this chapter 3. Once if you have done, please tell me, sir, done, sir. Otherwise, how should I understand?
Done, sir. Done, sir.
Yeah, great, great. Thank you. So let us start by fractions. Wow, here the girl is very happy. You can see in an image where the girl is very happy by doing the fractions, right? Here you can see there are many circles, Nana. There are many circles. In the first one, circle is not at all divided. It is whole, and then it is divided into 2 parts. So each part is 1 by 2, 1 by 2. Then it is divided into 3 parts, and the circle, each part became 1 by 3, 1 by 3, 1 by 3, then 1 by 4, 1 by 4, so on. And here 10 parts. Wow. That means it is appearing like pizza, no? Yeah. So please avoid junk foods in this era of pandemic. Please don't do that. Okay. So these all are fractions, Nana. When a whole is divided, we get some parts. We get some parts. Here, the whole circle is divided into 3 parts. In that, each part is called as fraction. So the part of a whole, is called as fraction. 1 by 3 is a fraction. 1 by 4 is a fraction. 1 by 5, 1 by 9, 1 by 10. Each part of the whole is called as fraction. Yeah. See, where we use these fractions, actually we use the fractions in our everyday life. Where, sir? For example, if somebody is asking you what is the time, your answer will be the time is 12:15. Now presently the time is quarter to 10. So what does it mean? Still 15 minutes is there to get 10. So here quarter is nothing but part. What part? 1/4. 1 by 4. If the total clock is divided into 4 parts, right? Total clock will have 60 minutes. Okay. So half of 60 minutes is 30 minutes. Now again, half of 30 minutes is 15 minutes. So 15 minutes is nothing but quarter for a clock. Then here we can see a boy is playing football, right? So Jack played really well in the first half of the match. So here the word half is nothing but it is a fraction. And how do we represent half? 1 by 2. 1 by 2 is half. 1 by 4 is quarter. Now here there's a girl, very cute girl, right? See, so Mia, her name is Mia, and she is 2.5 years old. 2.5. So 2.5 is also a fraction. You know what sort of fraction it is? Can you guess? 2.5 is which type of fraction?
1 by 2.
No, we have different types of fractions. In that 2.5 will be mixed fraction, Nana. 2.5. Okay. Yeah. Then this is a slice of pizza. Already 3/4 has been eaten somebody. So somebody has already eaten 3/4. 3/4 means 3 by 4. 3 by 4. 3 by 4 is eaten by somebody. And what is left? Only 1 by 4. So that is left for me, right? I will have it. Okay. So let me move ahead. Yeah. So what is a fraction? Fraction actually name parts of a whole. What does fractions name? They name parts of a whole. When I say 3 by 5, here 5 is whole. That means something is divided into 5 parts. Among that 5 parts, if you're talking about 3 parts, that 3 parts will be called as a fraction. So 3 by 5 is a fraction, right? So in this, the 3 is part, representing the part, and 5 is representing the whole. Please remember that. So among the whole, we are talking about 3 parts. The upper one is called as numerator. Please mute, Nana. Harsha, please mute, Nana. we call the top number the numerator. Here, what is the numerator? 3. 3 is the numerator. And what is it showing actually? It is the number of parts you have. And the down one, the bottom number, is denominator, and it is showing us the number of parts the whole is divided into. So please take screenshot of this quickly. Tell me done. Yeah. So if somebody is asking you, yeah, thank you. If somebody is asking you what is a fraction, what you have to say? You have to say that fraction is part of a whole. Fractions is part of a whole, or you can say that fractions name parts of a whole. Let me move ahead. Yeah. To understand it in a better manner, this is something, every time we are getting this figure, right? This is something like scary figure, but you don't get scary. Even that scary person is also trying to understand what is fractions. So we write fractions using a numerator and a denominator. Here 3 is the numerator and the bottom number is called denominator, right? The numerator tells us how many parts we have, and the denominator tells us how many parts something was or is divided into. Here you can see some chocolate, right? In the total chocolate is actually having 4 pieces, 1, 2, 3, 4, and unfortunately 1 piece is missing. Maybe Harshit, is it you who ate? No.
Not me.
Okay, not you. Yeah, I know. So here, among the four part, 1 part is missing. So how many parts are left? Only 3 parts are left. Yeah, it is 3 by 4. So if somebody is asking you how many part of the chocolate is eaten, 1 part is eaten. That is 1 by 4 is eaten. Now how many is remaining, or how many parts are remaining? 3 by 4 are remaining. Right? Yeah. Now you see here there are some buttons. You know buttons? Yeah. We use this on our shirts and sometimes on our pants also. So here we have totally 8 buttons. 1, 2, 3, 4, 5, 6, 7, 8. 8 buttons on the whole. That's why the bottom is showing 8. So there are 8 buttons altogether. Now among these 8, you can see that 5 buttons are green in color. 1, 2, 3, 4, and 5. So 5 by 8. Yes, very good. So if somebody is asking you how many parts are green, you have to say 5 by 8. Now, yeah, if I ask you how many parts of the buttons are pink, then what will be your answer?
3.
No, 3. It's 3 by 8. Okay, it's not 3. How many parts of the buttons on the whole are pink? You have to say 3 out of 8. 3 out of 8 are pink, right? Yeah, here it's a cake, Nana. The cake is divided into 6 equal parts and 5 parts are already eaten. Now only there is 1 piece of cake left. 1 piece is left out of 6, right? So the cake which was cut into 6 pieces is nothing but showing the number 6 here, denominator, and 1 part is still remaining. So if I'm asking you if I'm asking you how many parts of the cake are eaten, what will be the answer? 5? No, 5 by 6. Yeah, 5 by 6. 5 out of 6 are eaten and only 1 out of 6 is remaining. That's for me. Okay. Now this is a task for you. This is a task for you. And it's an open question. It's an open question. The first one is a circle, right? The first one is a circle. So the circle is divided into how many parts? It's an open question.
2 parts.
2 parts.
2 parts.
Yeah, very good. In that 2 parts, how many parts are shaded? How many parts are shaded?
1 part.
1 part is shaded.
1
Very
by
good.
2.
Wow, excellent,
1 by 2.
excellent.
1.
So it is
1 by 2.
Yeah, great. Just it is taking a moment to get the image ready. Yeah, now my image is ready. so this is 1 by 2. That's what you are telling, right? So 1 out of 2 parts is shaded. 1 by 2 is shaded. Now, can you tell here what is this shape called actually? What is this shape first? Please understand my question. What is the shape?
Circle.
Oval.
Circle.
Oval. Oval.
Like it is circle.
Oval.
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 Sir, numerator.
Half circle. Oval. Oval.
I don't know in your mobile laptop how it is appearing, but it is rectangle for me. It is a rectangle shape. It is a rectangle. How it is appearing oval for you?
Sir, second
It's a
one.
rectangle shape.
It is like
Yeah, second one. My cursor is at second one. Look.
Oh, second one. Is
Okay, tell me what is the answer? How many parts
One.
are shaded?
4 by 1.
1 by 4.
1 by 4.
How many parts are shaded?
1 by 4.
1 by 4.
1 by 4.
And 1
One. Oh,
by 4. 1 by 4. 4.
1 by
thank you. Everybody move. 1 by 4 is shaded. Here 1 by 3 is shaded. Now I am giving the answer. This is a triangle. So also in this part, out of 2 parts is shaded. And here, if you count 1, 2, 3, 4, 5, 6. So totally 6 out of 12. Totally 6 out of 12 are shaded,
By 12.
which will be again written as half. So half, yeah.
6 by 12.
And here totally 4 parts we have. In that 4 parts, 1 part is shaded. Here totally we have 3 parts.
1 by 4. 1 by 4. 1 by 4.
Third. The voice is
3 by 1. 4 by 1 by 4. 1 by 3, sir. 3 by 3.
I request everybody to mute themselves. Please, nobody will talk. Lekit, Harsha, or whoever. I am no more asking you because it is causing disturbance for the others, right? I will be calling you by name. If I call, then you answer. Otherwise, no need beta. So this was taken by me. So there are only 4 parts. In that 3 parts are shaded. Here we have 4 parts. 2 parts are shaded. That is, again, it is half, right? Half part is shaded. And here we have 1, 2, 3, 4, 5 parts totally. Totally, the whole is divided into 5 parts. In that one part is shaded. So this is how we represent the fractions diagrammatically, like this. Okay. If you want, you can take screenshot of this quickly and just show me thumbs up. Show me thumbs up.
Sir, done.
Yeah.
certain.
Yeah. So next, yeah, thank you, Beta. Now see, Beta, we are moving to the next thing, that is types of fractions. Types of fractions. Here we have diversified types of fraction. This is a slice of some pizza. Totally, it was 8 parts. Out of that, only 1 part is remaining. And here we have apples, like one apple is there and 2 slices are there, right? So it is represented as 1, 2 by 10. And here totally 12 parts of burger or something, I don't know, or whatever. So out of 12, only 1 part is remaining. And here only 1 part is eaten, and this is representing the 11 parts. Here we have some, what we call this as kiwi. It's 1.5. 1 is there and a half is there. And here the time is showing 55 by 60. So everybody knows, as you are in 6th grade, everybody is well aware of types of fractions. So let me tell you, the first one is proper fraction. Now, what do you mean by proper fraction? Here you have the definition. A proper fraction is a fraction whose numerator is less
smaller
than.
and denominator is bigger.
Very good, very good.
Numerator is lesser than the denominator.
Yes, correct. Thank you. Thank you. Now you see the examples. Examples are here: 3 on 4, 2 on 3, 15 over 20, 1 over 5, 1 by 2. So in all of these examples, the denominators are greater than the numerators. If you take 2 by 3, 2 is the numerator, 3 is the denominator. Here numerator is less than the denominator. So such fractions are nothing but proper fraction. So what do you understand here? That they are representing less parts of the whole. They are representing less parts of the whole. What? Proper fraction. Now please take a screenshot so that I can move to my next slide.
Sir, done.
Done? Thank you. Thank you. You should be quick
Done.
taking the screenshots. Yeah, beta. Yeah, obviously, you know that our next thing is improper fraction. So what is improper fraction? Have a look in the examples.
Numerator is greater than numerator.
One of you said numerator is greater than numerator. No.
Denominator is
Have a
greater
look
than
at the
numerator.
example.
Is greater than the denominator. Numerator
Thank you.
is greater.
Correct. Yeah. So shall I? So here in the example 5 by 4, you can see that the numerator is 5, denominator is 4. Means numerator is greater than 4. In the example 12 by 6, numerator is greater than 6. Just a minute. Let me control. 7 by 2. 7 is numerator. It is greater than denominator. I know that you are very excited, but please give me also some time to speak, no? Right? Then 9 by 3. 9 is the numerator and 3 is the denominator, beta. 9 is greater than denominator. But now here somebody was interrupting me. He or she was actually trying to tell, sir, that's okay. But even we have 8 by 8. So here 8 is not equals to 8, beta. Here numerator is not equals to the denominator. They are equal. Numerator is equals to denominator. So in such cases also, two conditions. Either numerator is greater than denominator, or if numerator is equal to the denominator, then also we call them as improper fraction. So that's the complete definition. An improper fraction is when the numerator is greater than or equal to. So that's put in the bracket, right? Numerator is greater than or equal to the denominator. We call them as improper fraction. I hope you got me, you understood me. So please take a screenshot. Please take a screenshot and tell me done, sir.
Sir,
Yeah, thank you. Now I will have my water. So until that, you can watch over the next slide. Yeah, read it out.
A mixed fraction is a whole number and a proper fraction together.
Whole number.
Whole part and fraction part.
Together.
Whole part and a fraction
Wow.
part. That much only.
Yeah, thank you, Harshit. I said to read it out, but I said to read among yourself, like,
Oh.
internally. Yeah.
Okay, sir.
Over here, you can see the examples are now 1.5. This is called 1.5, and this is called 3 2/3 or 2 by 3. 3 2/3 or 3 2 by 3. So in this, two different things we have. We have a whole number. One is a whole number, and 1 by 2 is a proper fraction. Definitely proper fraction, because just now we have learned that proper fraction is a fraction whose numerator is less than denominator. Right? Numerator is less than denominator. So here, if we are having a whole number, along with that, if we are given a proper fraction, right, then together it becomes what? It becomes a mixed fraction. Even in the second example also, you can see 3 is a whole number and 2 by 3 is a proper fraction. So here's something you need to understand, that every mixed fraction can be converted as improper fraction. Every mixed fraction can be converted as improper fraction. That is a fraction whose denominator is greater. Whose numerator is greater than the denominator, right? Same, every improper fraction also can be converted as mixed fraction. So in more clarity, what did I say? I said that mixed fraction can be converted as improper fraction, and improper fraction can be converted as mixed fraction. How? We will see that in our next slides, or after completing these slides. Yeah. So over here, you take the screenshot of this. Please take screenshot. Somebody is tapping something. Please mute yourself now. Please mute yourself, everybody. Good children, no? Yeah, thank you.
Sir,
Thank you.
Show me one.
Yeah, I have shown.
Sir, presentation.
It is coming, Nana. It is coming. See.
Done.
Yeah, thank you. Now we are getting one more slide in which we have all the types of fractions at one place. So I'm not going to read it, but definitely I will recommend you to take the screenshot. Take the screenshot. So this one slide will help you to identify all the different types of different types of fraction. We have proper fraction, right? We have improper fraction and mixed fraction. Mixed fraction consists of whole, along with that one more part, right? Yeah. So even here improper also you can see there is a whole and along with that one more part. So that's why this can be converted as this and this can be converted as this, right? 8 by 6 is equals to 1 2 by 6. You can see, right? Same figures. 8 by 6 is showing the same figure and 1 2 by 6 is also showing the same figure. We will understand it in a better manner, right? So apart from proper, improper and mixed, we are having like fractions, unlike fractions, equivalent fractions, right? So here's something which you need to understand. When I say proper fraction, I am talking about one fraction. Improper means again I am talking about one fraction. Mixed fraction means again I am talking about one fraction. But when we take many fractions together, and if they are having same denominator, here you can see 2 by 6, 1 by 6, 3 by 6, they are having the same denominator. Such fractions are called as like fractions. So how we can define like fractions? Thank you. How we can define like fractions? We can say that the fractions having same denominator are called like fractions. Are called means we are talking about many fractions, right? Yeah. Similarly, if the fractions are having different denominators, like you see here, we have 2, we have 3, we have 4. So all are different denominators. All are having different denominators. So such fractions which are having different denominators are called unlike fractions. Yes, Nana, unlike fractions. Correct. Now, let us understand the equivalent fractions. Here, 1 by 2 is representing the half of the pizza. 2 by 4 is also representing the half of the whole pizza. 3 by 6 is also representing half of the full pizza. That means what? They all are showing the same amount. They all are showing the same amount. Of course, that half is again divided into 2. That half is again divided into 6. But still, they are showing the same amount. So that's why such fractions which can be converted again as in the simplest form as 1 by 2. That is 2 by 4 is also 1 by 2. 3 by 6 is also 1 by 2. They are representing the same amount. Such fractions are called equivalent fraction. So please take a screenshot of this also, Nana.
Screenshot done.
Yeah, thank you.
Done, sir. Sir, done.
Yeah, hopefully I have gone a little bit speedy manner because you already know this was something like revision for you. This was something like just revision for you. We revised what is a fraction. Fraction is part of a whole. Then we saw types of fraction. In that we saw proper fraction. Proper fraction is a fraction in which numerator is smaller than the denominator. Then we define improper fraction, right? A fraction in which numerator is greater than the denominator. Numerator is greater than the denominator is called improper fraction. Then we define mixed fraction. What is mixed fraction? Mixed fraction is a fraction which is consisting a whole number or which is combining with a whole number and a proper fraction. I repeat, a proper fraction. That means 1 3 by 4 is a mixed fraction. So can't we write 1 4 by 3? No, 1 4 by 3 is not a mixed fraction. That is not simplified. Further we can simplify. How? We will see that later. Don't worry. Then just now we have seen like fractions, plural. Fractions having same denominator are called like fractions. Fractions having different denominators are called unlike fractions. And fractions which represent the same amount or fractions whose simplest form is the same are called as equivalent fractions. So that was types of fractions. Now we are moving ahead. Now we are moving ahead. Let us do the real task, that is operations on fractions. Yeah, this is what we are going to do. Now, what do you mean by operation? Taking a knife and again cutting and again stitching, that is operation? No, 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 no. In mathematics, we have 4 operations. What are those?
Addition, subtraction, multiplication, and division.
Subtraction, multiplication, division.
Very good, very good.
Addition.
Yeah, yeah, yeah. Everybody knows that. So they are called fundamental operations of mathematics or basic operations of mathematics. Yeah, you guys are right. First, we are going to compare the fractions, right? You know, comparison, who is bigger, who is smaller, or are they equal? Then addition of fractions. Then multiplication of fractions. You may ask me, sir, then where is subtraction? Already I said, when I do addition of fraction, in that only we will be again seeing subtraction. Yes, 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 yes. And after that, we will be seeing division of fractions one by one. One by one. So shall I start the operation? Ready?
Yes, sir.
Ready? Yes, sir. Thank you. So first, let me do comparison of fraction. Yeah. For that, I need to take a screenshot of this. First, we are going to learn comparison of fraction. Yeah. So I got a new. Just a minute. Let me crop it so that it appears bigger for you.
Slide.
Yes, Nana?
Sir, slide.
Yeah, just a minute. I'm just cropping it so that it appears bigger for you. Yeah, it's done. Yeah. Now, Sivita, let me take a question and then try to make you understand. The first question I'm taking here, compare, something went wrong, snip and sketch. Compare 5 by 7 and 2 by 7. Compare 5 by 7 and 2 by 7. This is my first question, right? So, you know, in solution, what we will be writing like this: given 5 by 7, right, and 2 by 7 and 2 by 7. First, writing what are the numbers which are given, the fractions. Now have a look. How do we do comparison? So before doing comparison, you have to first check whether they are like fractions or not. Whether they are like fractions or not. So what does it mean, sir? It means only like fractions can be compared easily. Only like fractions can be compared easily, right? So what does it mean? We cannot compare unlike fractions. We can compare unlike fractions also. But if it is like fractions, simply we can go like this. Over here, you see 5 by 7. Children, are you able to see the cursor? Where I am showing my cursor now? Where I am showing my cursor?
Sir, no, I can't see. Sir, up.
Now can you see? Upper.
Sir,
What do you mean by upper?
Sir, I can see now. Near Mithunjay
Fraction.
is presenting.
Sir, I can see presentation.
You're not able to see the presentation, Nana. Just a minute, wait.
Sir, we can see.
Okay, mute yourself. Yeah, thank you. Mute yourself. It's my mistake that I have asked you. Yeah. I should not have asked you, right? Yeah. I asked you and, I bothered you, everybody. Now, able to see, whatever I'm writing here.
Yes,
Now,
sir.
here, see? You're able to see?
Yes, sir.
Yeah. Good.
Yes, sir.
See, beta, here both denominators are same, so they are called as like fraction. Here the denominator is 7, here the denominator is 7, so they are called like fraction. So if they are like fraction, you need to check the numerators. Among the numerators, between the numerator, which is greater, that will be the greater fraction. So here So here, who is greater? Who is greater? Here, 5 by 7 is greater than 2 by 7. Why? Because 5 is greater than 2. So before seeing this 5 and 2, I have checked that 7 is equals to 7. That means they are like fractions. So if they are like fractions, then only we will check out the numerator, and then we will pick the numerator which is having bigger one, right? So 5 is bigger, right? So now how do we read this one? We read this one as 5 by 7 is greater than 2 by 7. That's great. That's great. Now let me take one more question, number second one. Now this time I'm taking compare 7 by 5 and 7 by 5 and some 5 by 2. I'm taking 7 by 5 and 5 by 2. Now tell me, are they like fractions? No, definitely they are not like fractions because their denominators are different. One is having 5 and the other one is having 2. So what we should do? Here we can do two things. We can do two things. Let me tell you the first thing. The first thing is convert the given unlike fractions as like fractions. Yeah, we can do that. We can convert the given unlike fractions. What are given? 7 by 5 and 5 by 2. Right? So what we have to do is, they are unlike definitely. First, you should take the LCM of the denominators. First, you need to take LCM of denominators. That is LCM of 5 and 2. LCM of 5 and 2 is what? 10. You know how to find LCM, right? You can do it by division method or prime factorization method. It's up to you. Now, 5 2s are 10. That's the LCM which we are getting. Now, let me write 7 by 5. That is the given first fraction. And then 5 by 2, that is the given second fraction, right? I have written. Now, what my attempt will be? My attempt will be in such a manner that the denominator 5 should become 10. The denominator 2 also should become 10, by which I can say that unlike fractions will be changed as like fraction. So how we are going to do that? This 5 will become 10 if you multiply into 2, correct? Yeah. Now the thing is, if you're multiplying, if you're multiplying something to the denominator, the same thing has to be multiplied to the numerator also. Why? So that the value of 7 by 5 doesn't change. Only its form will change. We will get equivalent fraction. We will get equivalent fraction of 7 by 5, right? Yeah. So what is 7 2s are? 7 2s are 14. And what is 5 2s are? 5 2s are 10. So 7 into 2, 14. 5 into 2 is 10. Now here have a look. 5 by 2, which was the given second fraction. Now this 2 should become what? The denominator 2 should become 10. Now when this 2 will become 10, if you multiply with 5. So 2 5s are 10. Now when you multiplied the denominator with 5, compulsory you have to multiply the numerator also with 5. And what you will get here? 5 into 5, the numerator. 5 into 5 is 25. 25 by 2 5s are 10. So here you can observe that the given questions were unlike fractions, 7 by 5 and 5 by 2. Now we converted them as like fractions, 14 by 10, 25 by 10. Both are having the same denominator, right? So they have been converted as like fractions. And when they are like fractions, you know what to do? Just pick the bigger numerator, 14 and 25. They are the numerators. Who is bigger? 25. So obviously 25. The symbol will turn towards 25 by 10, right? Yeah, but at last we should write therefore 14 by 10 is something which we are getting from 7 by 5. So 7 by 5, just a minute, excuse me, 7 by 5 is less than 5 by 2. That is 25 by 10 we are getting from 5 by 2. And 14 by 10 we are getting from 7 by 5. So the conclusion should be like this, because the given numbers only we have to represent finally. Yeah, now somebody was interrupting. Somebody was telling, sir. Who is that? Yes, Nana, tell.
Payal.
Wow, now nobody's talking. Yeah, Payal, क्या हुआ?
Sir,
Payal, बोलिए. What happened, Nana? Sai Shrestha, is my voice clear?
Yes, sir. Sir?
Yeah, Payal, tell me.
Sir, your voice is not clear.
Sir, your voice
Yeah,
is
I'm sorry
clear
for
to
that.
me.
Sir, it is clear.
Payal, before telling my voice is clear, you check your connectivity also, Nana. You can exit and again
Sir, I
rejoin.
have
No
checked.
problem. Yeah,
I
yeah.
have checked.
You can exit and again rejoin. Yeah, thank you, Payal. Thank you. Please mute yourself. If voice is not clear, once you exit and again rejoin and check. I have less time, Nana. Please try to be with me. Now, this was the first method which I said. Now I'm talking about the second method. In second method, we can do like this. Given 7 by 5 and 5 by 2. These are the two given fractions, right? So here what you have to do is, they are unlike fractions. In the first method, we have converted the given unlike fractions as like fractions, and then we compared the numerator. But here, we are not going to convert them. We are not going to convert them into like fractions. Instead, we will be doing cross multiplication, right? That is 7 into 2. So the 7 should be here. 7 numerator should be the left side, right? 7 into 2, comma, then we have 5 into 5. So that 5 into 5 I will be writing here, 5 into 5. Now what is 7 twos are? 7 twos are 14. Means we are getting the numerator when we convert. When we convert into like fractions, what numerator we will get? That numerator we are getting here, 14. And 5 5s are 25. You can see the same numerator which we will get after converting into like fractions, the same numerator we are getting here. Now tell me who is greater, 14 or 25? Obviously 25 is greater. So 25 is greater. Now 25 we are getting from whom? We are getting from 5 by 2 and 14. We are getting from 7 by 5. So here 7 by 5. So who is greater? 5 by 2 is greater. I think you understood how to compare the fractions. We are running out of time. So that's it for today, children. We have learned a lot of definition. We understood what's a fraction, types of fraction, and we did comparison of fractions. Now, please, thank you. Take a screenshot. Nana, homework. Homework I will give you, Nana. Please take screenshot.
The screenshot done.
Sir, done.
Sir, done.